Okay, you can see this is my petition on petitions.whitehouse.gov, and you can see I only have one signature, which is me, and 99,000 signatures to go by April 24th. And here is the what my petition says. And you can also see that this reactor, liquid fluoride thorium reactor, could save our planet from climate change. It could avert energy crises because it's naturally occurring on Earth, and you could, out of thorium, create uranium 233, which is so uranium 233 therefore does not occur in nature, but you could siphon it out of thorium. And uranium 33 burns very slowly, and there's almost no radioactive byproducts from thorium. So you need 100,000 signatures because, unfortunately, the Department of Energy is not allowing us to go into thorium. They're not approving it. Like, they're not saying we can't do it, but they're not paying for it. And they're getting rid of the uranium 233 that we do have. Okay, I'm gonna go to youtube.com and show you what thorium is. It's a video presentation made by Kirk Sorensen. There, thorium. See, it's already there. Thorium 2011 remix. Okay, there we go. An energy solution. Just watch and enjoy.
Constellations help explorers find new opportunities in
The heavy water reactor will use about 0.7% of the uranium's energy value, and the light water reactor will use about half of 1%. They both do terrible. At normal pressures, water will boil at 100 degrees Celsius. This isn't nearly hot enough to generate electricity effectively. So water-cooled reactors have to run at over 70 atmospheres of pressure. You have to build a water-cooled reactor as a pressure vessel. The number one accident people worry about, pressure is lost. Water that's being held 300 Celsius flashes to steam. Its volume increases roughly by a factor of 1,000. If you don't get emergency coolant to the fuel in the reactor, it can overheat and melt. This is what drives the design of this building. So if this happens, all the steam is captured in this building. Now the reactors...
These are the reactors we use today. Heavy and light water reactors. As he's saying, very bad and very dangerous.
We have today use uranium oxide as a fuel. It's a ceramic material, chemically stable, but not very good at transferring heat. If you lose pressure, you lose your water, and soon your fuel will melt down and release the radioactive fission products within it. So they have a series of emergency systems designed to always keep the core covered with water. We saw the failure of this at Fukushima Daiichi. They had multiple backup diesel generators, and each one probably had a very high probability of turning on. The tsunami came and knocked them all out. And sometimes say, is nuclear energy safe? And the first thing I say is, well, which one? Thousands of different ways to do nuclear energy. The other thing, is the car safe? Well, which one? I had the good fortune to learn about a different form of nuclear power, the liquid fluoride thorium reactor. We can fully burn up the thorium in this reactor versus only burning up part of the uranium in a typical light water reactor. It's not based on water cooling, and it doesn't use solid fuel. It's based on fluoride salts as a nuclear fuel. You have to heat them up to about 400 degrees Celsius to get them to melt. But that's actually perfect for trying to generate power in a nuclear reactor. Here's the real magic. They don't have to operate at high pressure. They don't have to use water for coolant, and there's nothing in the reactor that's going to make a big change in density. Unlike the solid fuels that can melt down if you stop cooling them, these liquid fluoride fuels are already melted. In normal operation, you have a little piece of frozen salt that you've kept frozen by blowing cool gas over the outside of the pipe. If there's an emergency and you lose all the power to your nuclear power plant, the little blower stops blowing, the frozen plug of salt melts, and the liquid fluoride fuel inside the reactor drains out of the vessel, through the line, and into another tank called a drain tank. In water-cooled reactors, you generally have to provide power to the plant. to keep the water circulating and to prevent a meltdown. But if you lose power to the lifter, it shuts itself down all by itself without human intervention. A staggeringly impressive level of safety, even if there's physical damage to the reactor. Thorium is a naturally occurring nuclear fuel that is 4 times more common in the Earth's crust than uranium. It's so energy dense that you can hold a lifetime supply of thorium energy in the palm of your hand. We could use thorium about 200 times more efficiently than we're using uranium now. And because the lifter is capable of almost completely releasing the energy in thorium, this reduces the waste generated over uranium by factors of hundreds and by factors of millions over fossil fuels. We're still going to need liquid fuels for vehicles and machinery, but we could generate these liquid fuels from the carbon dioxide in the atmosphere and from water, much like nature does. We could generate hydrogen by splitting water and combining it with carbon harvested from CO2 in the atmosphere, making fuels like methanol, ammonia, and dimethyl ether, which could be a direct replacement for diesel fuels. Imagine carbon-neutral gasoline and diesel, sustainable and self-produced. You can see that uranium-235 is like on par with silver and platinum. Can you imagine burning platinum for energy? And that's what we're doing with our nuclear energy sources today. We're burning this extremely rare stuff, and we're not burning thorium. You know, some people who are kind of environmentalists, and they say, listen, nuclear power is not sustainable. We're going to run out of uranium. Okay, I will yield that point to you if we're talking about today's nuclear technology. In 2007, we used 5 billion tons of coal, 31 billion barrels of oil, and 5 trillion cubic meters of natural gas, along with 65,000 tons of uranium to produce the world's energy. So I have a friend who's trying to start a rare earth mine in Missouri. Jim, how much thorium do you think you'll be pulling up a year? He goes, I think about 5,000 tons. 5,000 tons of thorium would supply the planet with all of its energy for a year. And he goes, and there's like a zillion other places on Earth that are just like my mine. It's a nice mine, but it's not unique. It's not like this is the one place on Earth where this is found. Every time mankind has been able to access a new source of energy, it has led to profound societal implications. Human beings have had slaves for thousands and thousands of years. And when we learned how to make carbon our slave instead of other human beings, we started to learn how to be able to be civilized people. Thorium has 1,000,000 times the energy density of a carbon-hydrogen bond. What could that mean for human civilization? Because we're not going to run out of this stuff. We will never run out. It is simply too common.
Okay, and as you can see, thorium is very common, and it's not just found on Earth. It's found on the moon. It's found on almost all the rocky planets of the solar system, on asteroids. It's found everywhere. Well, not on asteroids, but on like big planets. It's definitely found on Earth. It's going to be found on Mars. It's going to be found basically wherever there is nuclear, it's basically found, and I would say, in at least 40%, maybe to 50% of the solar system rocky bodies, especially in the asteroid belt, larger bodies, of course. But there's enough thorium in 5,000 tons to produce enough energy to supply the Earth's power for almost a year. So why should we have to stick with fossil fuels? Go into Iraq and Iran or whatever place for oil. What the heck are we doing? What a waste of time. Why can't we just... and there's another petition, thoriumpetition.com. This is not my petition. They had a petition, but the thing is, their petition expired. And I was a big supporter of this petition. Now I had to create my own, because now their petition's expired. The thing is, earlier they said 25,000. Now my petition needs 100,000 signatures. Oh my goodness. People, we gotta do it. If you want to save the Earth and secure your energy future and watch your electric bills plunge like a rock, please sign this petition. Because thorium will lower electric bills like 80-90% at least. You'll see electric bills go from $200 a month to maybe $50 a month. I guarantee you. Well, not a guarantee. That's if we go to thorium. So please, let's do thorium. It's for us. It's for the planet. It's not just for us. If you want to have world peace, thorium. If you want to have end of climate change, thorium. If you have asthma and don't want to suffer it anymore, thorium. The ultimate energy solution is thorium. And thorium cannot be weaponized. The waste products that are left over from thorium cannot be weaponized. This is why the US government shut down the thorium program in the 70s. Not because it was dangerous. No, thorium is very safe. It's because it can't be weaponized. And now that we are over the new Cold War, we can finally go back to thorium. Please, just let's do it. Thank you.